For the Founders Hall project, we really wanted the mass timber to be the element that made this building stand apart and to make it really shine kind of amongst every other building on the campus. One of the approaches that we took was not only to feature the wood on the interior of the building, but to also feature it on the exterior. So we did a lot of work to kind of think about how to express the mass timber on the exterior of the building so that anybody walking by could see that this building was different and was sort of special.
The big challenge was the seismic zone and using the CLT as the diaphragm itself to span as big as they can to keep rooms on a large size, which is 20-foot grids on this one, which is a fairly good span for mass timber.
The diaphragm layout on this building is complex. Each wing of that diaphragm can become a cantilevered element. So the amount of strapping and fastening is really key in those re-entering corners.
The specs of this building and stacking of follow-on trades and the overall construction schedule was critically important. And what we did to mitigate this is use very large mass timber panels. They snap into place and we can knock out 10,000 plus square feet in a day without the concrete that would be required to go to your next floor. The universities tend to be very progressive in their thinking. They have students looking and studying what's next. So I think mass timber lends itself great to universities looking to stay on that forward-thinking edge. Builders would pick mass timber over traditional construction materials like concrete or steel for a couple reasons. First being speed of construction, which has downstream impacts related to cost savings and potentially incentives. The second is just crew size and keeping the site cleaner than a traditional construction material might have.
Mass timber really builds out the ability to digitally fabricate your building, leveraging design to fabrication in an efficient manner. Mass timber provides opportunity for good cost certainty and schedule certainty on site because it forces the design and approvals process to be upstream. What is on the architecture and structural drawings, every piece count can be identified, and it gives you a certainty on site to build quickly with lightweight material compared to a precast concrete. It can be 1/3 to 1/5 the weight. And then the fasteners that put it together on site are handheld screws with simple tools.
Overall, the carbon impact is something that is huge for GCs, but most importantly, the clients choosing the material. There are a lot of corporate goals with big companies, tech companies, as well as others to reduce their carbon footprint, and this is a great way to do that.
It really sits in the embodied carbon or the embodied effects of that structure. And that's where timber is so interesting and part of that conversation.
The developer clients are looking out for their end users. Typically they're looking at biophilia and how people are feeling, the wellness inside their buildings. And then related to their bottom line, we're seeing higher leasing velocities both in office and multifamily space. And then at least a couple of our finished jobs have showed higher rent due to the perceived benefits and actual benefits of living in such spaces.
That appeal of the wood is compelling to me. I think it's compelling to many. And of course, the motivation and the solutions we bring for buildings is to leave as much of that wood exposed for the end use of the building. So the smell, the feeling, and the natural daylighting that can come into these spaces make them kind of one of a kind.
In this particular project, we used metal splines, Simpson Strong-Tie strap splines, plywood splines, as well as the giant collector plates. Simpson Strong-Ties had a fastener that met every need for every different spline.
Simpson Strong-Tie fasteners were used for panel-to-panel connections at spline joints, where we have a strip of plywood and two panels abutted together. They're also the longer screws that are used where the CLT sits on a glue lamp support and you can simply fasten it together with a handheld tool on site with no pre-drilling and no pilot holes. Those are really key. And in addition, in this diaphragm solution, one way to get those solutions to work is to fabricate steel plates, which is expensive and heavy, but the coil strapping and the gauge metal elements that Simpson has is also tested and in their catalog for economic use as a diaphragm connection system.
Simpson Strong-Tie is an easy choice for us because we know all the testing that they've done. We've used them on other jobs, we've seen them on other jobs, and there's really no industry question about their quality. The service is great because it covers all aspects of our needs, from design through project management and procurement to our field guys. So like any construction job, we run into issues on site, and we're always looking for back pocket solutions we can have handy for these quick fixes. which is one of the main reasons we enjoy working with Simpson, is because we have their products on site. We know where we can get some for tomorrow or the next day if we need it.
To see Simpson Strong-Tie commitment to develop solutions for mass timber buildings is really essential. Their presence in the marketplace across the country, their ability to educate engineers across the country on how to properly design with mass timber efficiently is invaluable, and it's really proving to me that the wheels are in motion, that this is going to be only a growth industry in the future.
I think in 10 years we're going to see a lot of change in the industry. I think there will be a lot more built mass timber projects. As people see more and more projects, more and more people are going to want to move in that direction. The interest is gaining and snowballing, and everybody wants to talk about it and hear, is it possible for us? Could we do it? What does it mean? Where could we take it? So I think the future is very promising for mass timber.